When installing a subpanel, compliance with the National Electrical Code, specifically Section 110.26, is critical for safety and to meet inspection requirements. Section 110.26 addresses the working space about electrical equipment. Let's consider the two proposed locations for the 100 amp subpanel left of the main panel and below the main panel, and analyze their compliance with the NEC. Firstly, consider the option of installing the subpanel to the left of the main panel. The primary concern here is NEC Section 110.26c, which mandates a minimum of 3 feet of clear working space in front of electrical equipment. This working space must be clear and unobstructed to allow for safe operation and maintenance of the electrical equipment. The presence of a wall just 1 foot away from a portion of the subpanel, even with doors intended to provide access, introduces a violation of this code. Specifically, if the leftmost 3 to 5 inches of the subpanel only have 1 foot of depth, even with the doors fully opened, it fails to meet the 3-foot clear working space requirement. The fact that the subpanel door can open 90 degrees or that the breakers have clear space in front of them is irrelevant. The code requires 3 feet of clear working space in front of the entire panel, not just parts of it. Obstructions that reduce the space, even partially, constitute a code violation. Secondly, consider the option of installing the subpanel directly below the main panel. While this might seem like a space-saving solution, it presents its own set of challenges, mainly related to safety and accessibility. NEC Section 110.26a emphasizes the need to minimize the likelihood of accidental contact or damage to electrical equipment. Mounting the subpanel directly below the main panel could create a tripping hazard. Anyone working on the upper panel might inadvertently come into contact with the lower panel or its wiring, increasing the risk of electrical shock or other injuries. Furthermore, this arrangement could make it more difficult to access and work on either panel safely. The close proximity of the two panels could also impede proper ventilation and heat dissipation, potentially leading to overheating and premature failure of electrical components. It's crucial to ensure that any electrical installation allows for easy and safe access for maintenance, repairs, and future modifications. Placing one panel directly above another compromises this accessibility and increases the risk of accidents. Given these considerations, installing the subpanel directly below the main panel is generally not recommended, primarily due to safety concerns and potential accessibility issues. Therefore, installing the subpanel to the left of the main panel violates NEC Section 110.26c, and installing it directly below the main panel is not recommended due to safety and accessibility concerns. Now, let's explore some recommended solutions to ensure code compliance and safety. Firstly, consider installing the subpanel in a different location that meets the 3-foot clear working space requirement. This could involve moving the subpanel to a separate wall where there is ample space in front of it, or locating it in a utility closet that provides the necessary depth. When choosing a new location, consider the accessibility of the subpanel for future maintenance and repairs, as well as the overall layout and functionality of the space. Ensure that the new location meets all applicable electrical codes and regulations. Secondly, consider installing the subpanel on a raised platform or enclosed within a cabinet to provide the necessary depth. This approach can be particularly useful in situations where space is limited or where it is necessary to protect the subpanel from damage. A raised platform can elevate the subpanel to a more accessible height, while a cabinet can provide additional protection and security. Ensure that any platform or cabinet is constructed of durable materials and is properly grounded to prevent electrical hazards. When selecting a cabinet, choose one that is specifically designed for electrical equipment and that meets all applicable safety standards. In summary, when installing a subpanel, prioritize safety and code compliance by carefully considering the location and accessibility of the equipment. Avoid locations that violate NEC Section 110.26c or that compromise safety or accessibility. Explore alternative solutions, such as relocating the subpanel to a more suitable location or installing it on a raised platform or within a cabinet to ensure that the installation meets all applicable requirements. Remember, proper planning and execution are essential for ensuring the safety and reliability of any electrical installation. Always consult with a qualified electrician or electrical inspector if you have any questions or concerns about the installation process. They can provide valuable guidance and ensure that the installation meets all applicable codes and regulations. In addition to the physical placement of the subpanel, it's also important to consider the electrical connections and wiring. Ensure that all wiring is properly sized and installed in accordance with the NEC. Use appropriate connectors and terminations to ensure secure and reliable connections. Label all circuits clearly to facilitate future maintenance and troubleshooting. Grounding is another critical aspect of subpanel installation. Ensure that the subpanel is properly grounded to prevent electrical shock hazards. Use a grounding electrode conductor of the appropriate size to connect the subpanel to the grounding system. Test the grounding system to verify its effectiveness. Overcurrent protection is essential for protecting the subpanel and its connected circuits from overloads and short circuits. Install circuit breakers or fuses of the appropriate size in the subpanel to provide overcurrent protection for each circuit. Label each circuit breaker or fuse clearly to indicate the circuits it protects. When working on electrical equipment, always follow safe work practices. De-energize the circuit before working on it. Use appropriate personal protective equipment, such as gloves and eye protection. Never work on electrical equipment when you are wet or standing in water. If you are not comfortable working on electrical equipment, hire a qualified electrician to do the work. Electricity can be dangerous, and it's important to take precautions to protect yourself from injury. The NEC is a comprehensive set of standards that covers all aspects of electrical installations. It's important to be familiar with the NEC requirements that apply to your specific installation. Consult the NEC for detailed information on wiring methods, grounding, overcurrent protection, and other electrical topics. Local building codes and regulations may also apply to your subpanel installation. Check with your local building department to determine the applicable requirements. Building codes and regulations are designed to protect public safety and ensure that electrical installations are safe and reliable. Electrical inspections are typically required for subpanel installations. Contact your local building department to schedule an inspection. An electrical inspector will review the installation to ensure that it meets all applicable codes and regulations. Passing the electrical inspection is essential for ensuring that the installation is safe and compliant. Subpanels are an important component of residential electrical systems. They provide additional circuits for powering lights, appliances, and other electrical devices. When installing a subpanel, it's important to follow all applicable codes and regulations to ensure that the installation is safe and reliable. A properly installed subpanel can provide years of trouble-free service. If you are planning to install a subpanel, take the time to plan the installation carefully. Consider the location of the subpanel, the size of the subpanel, the wiring methods, the grounding, and the overcurrent protection. By planning the installation carefully, you can ensure that the subpanel meets your needs and that it is safe and reliable. Remember to always prioritize safety when working with electricity. If you are not comfortable working on electrical equipment, hire a qualified electrician to do the work. Electricity can be dangerous, and it's important to take precautions to protect yourself from injury. Following these guidelines will help you ensure safe and code-compliant subpanel installation. Always consult with a qualified electrician or electrical inspector if you have any questions or concerns. Understanding the nuances of electrical codes and best practices is crucial for any electrical project. Before commencing any work, a thorough review of the electrical load calculations is essential. This process involves determining the total electrical demand of all the devices and appliances that will be connected to the subpanel. Accurate load calculations will ensure that the subpanel is adequately sized to handle the anticipated electrical load without overloading. Consider the potential for future expansion when sizing the subpanel. It's often wise to choose a subpanel with a higher amperage rating than initially required to accommodate future electrical needs. This will avoid the necessity of upgrading the subpanel later on. The selection of appropriate wiring methods is another critical aspect of subpanel installation. The NEC specifies various wiring methods that are suitable for different applications. Common wiring methods for subpanel installations include non-metallic sheath cable, also known as type NMB, and metallic conduit. The choice of wiring method will depend on factors such as the environment in which the wiring will be installed and the local building codes. Proper grounding is paramount for electrical safety. The grounding system provides a low impedance path for fault current to return to the source, which helps to trick the circuit breaker and prevent electrical shock hazards. The grounding system should be installed in accordance with NEC requirements. This includes the use of a grounding electrode conductor of the appropriate size to connect the subpanel to the grounding electrode system. Overcurrent protection is designed to protect electrical circuits from overloads and short circuits. Overcurrent protective devices, such as circuit breakers and fuses, are designed to interrupt the flow of current when it exceeds a safe level. The overcurrent protective devices should be sized to protect the conductors that they supply. It is crucial to select the correct type and size of overcurrent protective devices for the subpanel installation. Proper labeling is essential for identifying circuits and components within the subpanel. All circuit breakers and fuses should be clearly labeled to indicate the circuits that they protect. This will facilitate troubleshooting and maintenance in the future. It is also a good practice to label the subpanel itself with its voltage and amperage rating. When working with electrical equipment, always follow safe work practices. De-energize the circuit before working on it. Use appropriate personal protective equipment, such as gloves and eye protection. Never work on electrical equipment when you are wet or standing in water. Electricity can be dangerous, and it's important to take precautions to protect yourself from injury. If you are not comfortable working on electrical equipment, hire a qualified electrician to do the work. A qualified electrician has the knowledge and experience to safely and correctly install a subpanel. They can also ensure that the installation meets all applicable codes and regulations. Hiring a qualified electrician is a wise investment that can protect your safety and ensure the long-term reliability of your electrical system. Remember to obtain the necessary permits and inspections before commencing any electrical work. Local building codes and regulations often require permits and inspections for subpanel installations. Contact your local building department to determine the applicable requirements. Obtaining the necessary permits and inspections will help ensure that the installation is safe and compliant. Electrical codes and regulations are constantly evolving. It is important to stay up to date on the latest changes to the NEC and other applicable codes. This will help you ensure that your electrical installations are always safe and compliant. There are many resources available to help you stay informed about electrical codes and regulations. These include the NEC, electrical trade publications, and continuing education courses. By staying informed, you can protect your safety and ensure the long-term reliability of your electrical system. Planning the layout of your subpanel is crucial for efficiency and safety. Firstly, consider the physical space available. Measure the area where the subpanel will be installed, taking into account any obstructions or limitations. This will help you determine the maximum size of the subpanel that can be accommodated. Secondly, determine the number of circuits required. Make a list of all the devices and appliances that will be powered by the subpanel and calculate the amperage required for each circuit. This will help you determine the number of circuit breakers or fuses that will be needed in the subpanel. Thirdly, consider the location of the subpanel in relation to the main panel and the loads it will be serving. The subpanel should be located as close as possible to the loads it will be serving to minimize voltage drop and improve efficiency. It should also be easily accessible for maintenance and repairs. Fourthly, plan the wiring routes. Determine the best way to route the wiring from the main panel to the subpanel and from the subpanel to the loads. The wiring should be installed in accordance with NEC requirements, using appropriate wiring methods and supports. Fifthly, label all circuits and components clearly. Use a permanent marker or label maker to label all circuit breakers, fuses, and wiring connections. This will make it easier to identify circuits and troubleshoot problems in the future. Proper documentation is essential for any electrical installation. Keep a record of all the materials used, the wiring diagrams, and the test results. This documentation will be helpful for future maintenance and repairs. It is also a good practice to take photographs of the installation before and after it is completed. These photographs can be helpful for documenting the wiring routes and connections. Safety is always the top priority when working with electricity. Always de-energize the circuit before working on it. Use appropriate personal protective equipment, such as gloves and eye protection. Never work on electrical equipment when you are wet or standing in water. If you are not comfortable working on electrical equipment, hire a qualified electrician to do the work. Electricity can be dangerous, and it's important to take precautions to protect yourself from injury. Always double-check your work to ensure that everything is connected correctly and that all safety precautions have been followed. A thorough inspection of the installation is essential before energizing the circuit. Use a multimeter to test the voltage and continuity of the circuits. Make sure that all grounding connections are secure and that the overcurrent protection devices are properly sized. If you find any problems, correct them before energizing the circuit. Regular maintenance is essential for ensuring the long-term reliability of your electrical system. Inspect the subpanel and its components regularly for signs of damage or wear. Tighten any loose connections and replace any damaged components. Test the circuit breakers and fuses periodically to ensure that they are functioning properly. By performing regular maintenance, you can prevent problems and extend the life of your electrical system. Troubleshooting electrical problems can be challenging, but there are some basic steps you can follow to identify and resolve the issue. Firstly, start by checking the circuit breaker or fuse. If the circuit breaker is tripped or the fuse is blown, reset the circuit breaker or replace the fuse. Secondly, check the wiring connections. Make sure that all wiring connections are tight and secure. Look for any signs of damage or corrosion. Thirdly, test the components. Use a multimeter to test the voltage and continuity of the components. This will help you identify any faulty components. Fourthly, consult a qualified electrician. If you are unable to resolve the problem yourself, consult a qualified electrician. They have the knowledge and experience to safely and correctly diagnose and repair electrical problems. Staying informed about electrical safety is crucial for protecting yourself and your family from electrical hazards. Learn about the common causes of electrical accidents and how to prevent them. Follow safe work practices when working with electricity. Use appropriate personal protective equipment. Never work on electrical equipment when you are wet or standing in water. By staying informed and following safe work practices, you can reduce the risk of electrical accidents.